السلام عليكم. فيديو جديد. أنا توني وهذا فيديو لصف 11 متقدم Chapter 5 Kinetic Energy Work and Power Part 1. Part 1 الجزئية الخاصة بالنظري، وفي الجزئية الثانية الخاصة بالعملي أو حل المسائل اللي هي Part 2 إن شاء الله ل next week. أوكي، في بعض المسائل موجودة على كلاس كيك، وهذا هو الكود والرابط إن شاء الله بالديسكريبشن. EEK5RU كود حق الكلاس كيك. Bon, we continue. هذه ال objectives for our lessons. 7 objectives، بس في عنا one objective 4 جزئية منه هي إثرائية. So all of them are required, but one objective is for enrichment. Okay. إن شاء الله يزبط التسجيل لأن صاروا 3 مرات. Okay. Energy in our daily lives. So that's the first section. أكيد. They introduce in our book. They introduce the concept of energy as this statement. So no physical quantity has greater importance in our daily lives as or than energy. So they are trying to tell us that energy is so important and it's worth studying this concept, the concept of energy, because as you know, you can find energy everywhere, and energy defines lots of defines the life that we are living, by the way. Okay, so it's worth studying the energy. Okay, so food is example of energy intake, and the exercise that we do is energy is example of energy consumption. Okay, أكيد the unit of energy is joule, I assume, or that you all familiar with that. So by definition, energy is what? Energy is the ability to do a work. Okay, it's the ability, underline ability please, because later on I'll tell you why they say ability. So energy is the ability to do the work. Okay, because sometimes I have energy but I decide not to do a work. We'll discuss later on this later on. So another example of energy are the renewable energy sources and non-renewable energy resources. They discuss these two topics. They've been discussed deeply in COP28 last month in Dubai. Example of renewable energy resources are the solar energy, wind energy, and tidal energy. Okay. Example of energy intake, the food. We discussed this. In section 2, the kinetic energy. So kinetic energy is type of energy, but this energy is associated with motion, with movement, بالحركة. Every time كل مرة بكون عندنا حركة, so then we talk about kinetic energy. And this energy is equal to half mv square. m expressed in kilogram، الوحدة كيلوغرام، والسرعة الفيلوسيتي الوحدة مالها متر per second متر per second بس. Okay, so as I told you كل مرة بيكون في عندنا motion حركة، يعني we are talking about kinetic energy. This energy could be equal to 0 if we are at rest. At rest means there is no motion، ما في حركة. Okay. Also, as I told you, unit of energy is joule أكيد. Another a small example here. We have a car of 1,310 kilogram moving at this speed, 24.6 meter per second. So you can stop the video, or yeah, you can try to solve this question. We have the mass and the velocity. So what would be the kinetic energy of this car? Yes, the energy. So we simply apply the equation half mv square, and the answer is 4 by 10 power of 5 joule. We continue with question 19. الإضاءة ما كثير عجبتني بالفيديو، لحظة. Oh, okay. Question 19. Okay, the damage done by a projectile on impact is correlated with kinetic energy. So here we have three cases, A, B, and C. We have to calculate the kinetic energy for all of them. So first we have a stone, 10 kilogram, and its speed is 30 meters per second. So what would be the kinetic energy here? Half mv square. What about question B and C? Here in B and C there is a small trick. There are a small trick. The mass given is in gram, so we have to convert it to kilogram. How to go from gram to kilogram? By dividing by 1000. Okay, so that's what we did. 100 gram now turned to 0.1 kilogram, and 20 gram becomes 0.02 kilogram. Well, we continue. This is slide 1 on ClassKick. If you go, this is the code. I give you the freedom to solve this anytime till next week, because I will go through it and correct your answers, by the way. Okay, so you have the space to solve this question. So what's given? The mass of the tiger and its energy, and they ask for the speed. It's a speed. Okay, still with the kinetic energy, we have the spectrum. This is the kinetic energy spectrum. As you know, or as I introduced to you, energy or kinetic energy is associated with motion, حركة. And motion is everywhere, from a small atom to the biggest galaxy. Everything is moving. Okay, so it's interesting also to understand the kinetic energy. Okay, as I told you, the unit of energy is joule. But what if we are talking about very or extremely small objects like atoms or electrons? So joule, اليونت joule بتصير كبيرة، it becomes heavy. Okay, to describe the motion of very or extremely small uh, objects. Okay, so what to do here? We convert from joule, or we go from joule to electron volt. So it's good to note that 1 electron volt is equal to 1.602 by 10 power of minus 19 joule. Okay, this is the atomic scale. Okay, if we are talking about food, if someone also is interested in diet or like to be a dietitian one day, so it's good to know that 1 calorie is equal to it's equal to 4,186 joule. الله رواني. Okay, 4,186 joule. Okay. Okay, section 3. Also, please, I need someone, please, I will appreciate that. If someone can tell us the section and the page, write the page in the book. That will be helpful, and I will appreciate that because I forgot to mention the page. Okay, so by definition, what's work? Work is the energy. Work is energy. شو رأيكم? Both of them have the same unit, work and energy. So why we have the concept of work? Energy is not enough to describe things. Why we have to study work? Look at that. Work is energy transferred يعني عم تنتقل from one body to another body, from one object to another object. Okay, how? Using a force. So الورك هي الانرجي اللي عم تنتقل من جسم للتاني from one object to another object. How? By using a force. Here is a small example. We have a boy pushing a desk. Okay, so الانرجي اللي كانت بالبوي انتقلت للديسك. How? By using a force, the force of the hand. Okay, so انتقلت الديسك from this place to another place. So as you see, work depends on two factors. As you see here from the picture, work depends on the force and the distance as well. Another example here, we have, this is section 4, by the way, work done by a constant force. So we have a small box, we are pushing it by 500 Newton, and the angle is 30 degrees with the horizontal. The box is moved to 20 meters. So what will be the work here in this case? So we simply apply the equation, force by distance by cosine the angle. The angle in this case is 30 degrees. Okay, and the answer is 8,660 joule. Okay, still in the same section here, talking about the angle in this concept check 5.1. So it's interesting to know the angle. Oh, I forgot to put silent. Wait, sorry. Okay. Okay. Sorry. Okay, so concept check 5.1. We have the force. We have delta R. Delta R is the displacement, as we see in the previous slide, or as we saw. Okay, so two vectors. In the first case, they are parallel and they both have the same direction. Okay, so what would be the angle here in this case? The angle is 0. I'm interested to know or to understand the angle, because in the equation of the work, there is angle. So force by distance by cosine the angle. So I have to know the angle. Okay, so in the first case, the angle is equal to 0, and the cosine is and the work is positive. In the second case here, the both vectors are parallel, yes, but in opposite direction. The angle is 180 degree. Cosine 180 degree is equal to -1. Okay, as you see here, cosine 180 is equal to -1, and here both vectors are perpendicular. Cosine 90 is equal to 0. So here in this case, there is no work, even if you are applying energy and force here in this case, in this direction. Okay, the force applied in that direction, but the displacement is totally perpendicular. So in that case, work will be 0. Still in the same section, 5.4, work done by a constant force. Yes, the example of constant force is the force of gravity. Force of gravity is constant, okay, because gravity is constant. Okay, so Fg equal mg, and as we studied, the work is equal to force by distance or delta r by cosine the angle. So إذا بنسوي تعويض 1 and 2, we replace 1 and 2, we got a new equation, not a new equation, but a new expression. Okay, so instead of F, now it's mg. So work equal mg instead of force of gravity multiplied by delta r here multiplied by cosine the angle. Okay, the most important idea I think in this chapter is this one. The work of gravity as described here is mass or mg delta r cosine the angle is equal, so this expression is also equal to the change in kinetic energy delta k or the change in the kinetic energy. Okay, so the change in the kinetic energy, or إذا بدكم change in velocity, in other words, okay, is proportional to the work, is equal to the work of force of gravity. Okay, so this is what we call by work kinetic theorem. It's equivalent to Newton's second law, and that's how we write it. Delta k is equal to the work. Okay, we are halfway through, تقريبا وصلنا النص, and already 20 minutes. So easy question, work kinetic energy theorem is equivalent to which law? Yes, it's in Newton's second law. Okay, example also on Classic. You have the space to solve this question. We have Jack moving. He is walking for a distance and holding a box, moving at a certain speed. So how much work this guy is doing, or Jack done on the box? Okay, so you have to calculate the work. And that's for slide 2 on Classic. Okay, we continue with this picture here also. We have two cases, as you see. Okay, first case, a baseball moving downward. Force of gravity is down and the displacement of the ball is down. So what's the angle between the two vectors here? They are parallel, yes, and same direction. So the angle between them is 0. So cosine 0 in this case is +1. So the work, which is F multiplied by D or distance, force of gravity is mg, multiplied by the distance. Here the ball moved down for a certain distance called h. So it's plus, the work here is positive because both vectors are on the same direction. Look at the second case. Here the ball is moving up, it's going upward, but the force of gravity is always downward. So here the angle is 180 degree. Cosine 180 is -1. So that's why you see minus here. So work, as you see, could be positive and could be negative. Okay. Still in section 4, work done by a constant force. A German lifter, Ronnie Weller, won a silver medal on the Olympic Games in Sydney. He lifted 257 kilogram for a height of 1.83 meter. So what's the work done by this player? Okay, so what's the work? أكيد force by distance. So what type of force here? Yes, أكيد force of gravity. Okay, which is mg multiplied by the distance. How much he is moving that weight, that heavy weight? It's 1.83 meters. So you multiply this expression and you got the answer, which is 4.662 kilojoule. Now moving to section 5, the work done by a variable force this time. In the previous section, it was about constant force. Now talking about a variable force. To calculate the variable force, there is a small trick here. You have, okay, look at this picture first. The force in this case is not constant, as you see. It's moving up and down, right? It's down and up. It's not stable. So how to calculate the work in this case? Please take note of this important sentence. The work in this case is an area. It's the area under the line. So that's the area. So if we calculate the area, we calculate the work done by that force. Okay, there is another way also, how using the integral or the mathematical way. So work is equal to the integral of the force in respect to x. Okay, we'll do x. I'll give you an example for both ways. How to calculate the work in case of a variable force. So the first example here, as you see here, we have the force in the y-axis and the displacement on the x-axis. Okay, so the force is not stable. It was stable at first, and then it decreases in value, right? It drops down. So how to calculate the work in that case? By calculating the area. So what's the area of the first shape? The area of the square. Area of the square, أكيد it's side multiplied by side, which is in this case 5 by 5, and the answer is 25 meters square. What about the triangle? What's the area of the triangle? It's height multiplied by base over 2. Okay, h multiplied by base divided by 2, and the answer is 20.5 joule. So the total work is the sum of the area of the work, area of the square plus the area of the triangle, which is 37.5 joule. Okay, here is another example. Okay, to practice your math skills on ClassKick. Inshallah, next week I will upload a video solving those questions. Okay, 5.6 is spring force. The force of the spring is equal to minus k multiplied by x. Okay, let's start by defining x. What do you mean by x? X is the extension of the spring. As you see here, we have a spring. When we attach the mass to the spring will extend, become longer, right? So that's extension. هذه المسافة اللي طولها، الفرق بين الأول والثاني، هذه المسافة نسميها ال x, the displacement of the spring. ال k is the spring constant. Okay, هي بتقلنا ال k بتقلنا إذا ال spring هو strong or weak. Okay, والماينس أكيد الماينس of the spring because in the equation we always have minus. Okay, here in case of spring, because the spring always react opposite to the main force. For example, if I'm trying to extend the spring, I'm جرب شد الspring, the spring will bring me up, right? Also the opposite, if I'm trying to compress the spring, I'm حاول اضغط الspring, the spring will push me down. So the spring always acts in opposite, react opposite way. So that's why, or that's the reason behind the minus. So force of the spring equal minus kx. Here is a small example on slide number 4 on ClassKick. The mass is given, the extension is given, the first and the second extension are given. So what's the value of the spring constant k? So you have to calculate k. So this is a small tip by me. I make the drawing and you can continue. So now we study the force of the spring. Now it's time to study the work done by the force of spring. We call it Ws. Ws, which is equal to minus half kx square. Again, x is the extension of the spring and k is the spring constant. You can try to solve this question also on slide number 5, number 42 on chapter 5. I continue with the last section about the power. ما شكل حطيته silent. Okay. Yeah, section 7, the power. So يعني كل اللي درسناه بchapter 5 توصلنا على فكرة الباور. Okay, everything we study in chapter 5 to reach this point, to understand the concept of power. Okay, منيح بعدنا less than 20 minutes. Okay, so what's power? Power is the work. Power هو الwork. what. So شو الفرق بين الباور والwork؟ why we study two concepts؟ شو الفرق بين ليش we have power we have work؟ ليش بنحب نعقد القصص؟ no, look at that. Power is the work but in respect to time. rate. okay, rate هي كلمة السر. rate means in respect to time. so power is the work okay in respect or depends on the time. rate. تتذكروا هالكلمة rate مرقت معنا بترم 1 when we studied the velocity and acceleration. قلنا إنه acceleration is the rate of the velocity يعني velocity over time, right? So here the same. Power is equal to the work as you see but divided by the time. Okay, so that's how we define the work. Power, sorry, that's how we define the power. Power is the rate at which work is done. I give an example here, a small example. Let's say I'm walking 10 meter. Okay, it took me, let's say, 1 minute to walk 10 meter off. Okay, let's say I'm walking 10 meter, 1 minute for 10 meter. My friend is running. Okay, my friend is running 10 meter and he covered the distance in let's say 10 seconds. Right? اثنيناتنا قطعنا نفس المسافة بس هو عملها بوقت أقل. So الورك هو عنده أعلى من عندي. سوري الباور يا الله. الباور exert by my friend is more than the power done by me. اوكي هذه هي concept الباور. يعني اثنيناتنا مشينا نفس المسافة. We did the same, I think the same power, but yeah, we did the same work but different power. Sorry. Unit of the power is W, which is the watt. Please don't be confused as me between the work and the watt. Okay, unit of power هي الوات والwork is a parameter itself and the unit of the work is joule. Okay, continue here with the easy questions. Which of the following is correct unit of energy? Okay, let's take for example the idea of kinetic energy. Half mv square. Okay, الماس is in kilogram والvelocity meter per second but we have square so هذا السكوير تتوزع على الام والاس. So تشبه الكيلوغرام M2 S2. So answer is C. Okay, let's take another example or another question. 5.5. Which of the following is correct unit of power? W. Watt. Unit of the power. Yeah, we are about to finish. A few or 1 or 2 minutes and we everything will be over. So the power مثل ما اتفقنا انه هي الwork over time. والwork إذا بتتذكروا بداية الباوربوينت الwork هو ال change of the kinetic energy delta K which is half mv square. So هذه الهاف تنزل لتحت على denominator. So now we can write that power, the average power, is equal to mv square over double the time, mv square over 2t. So we can use it all the way. Okay. Yes, you can use it here. You can use this previous equation to solve question 6 or yes, on slide 6. So here we have a car going a specific mass going at a speed and at a certain time. Okay, so what's the power delivered? Okay, so you have to calculate the power and then convert it to HP, to horsepower. يلا still in the last section. الإضاءة مش عجبتني بس ما أعرف الإضاءة مش كتير منيحة. Anyway خلصنا الفيديو هلا مش حرزين نغير. Okay, 5.7. Okay, I think we'll finish with this idea. For a constant force the work done. Okay, مثل ما اتفقنا انه الwork هي force by distance, right? So we can write this. Power is the change in the work over time. الwork خلينا نقسم الwork هي الforce by distance. الforce let's say انه الforce constant. So مين عم يتغير؟ distance delta r over dt. dr over dt بتذكركم بشيء change of distance over change of time. هو شو بالترم 1 إذا تتذكروا هو velocity, right? So now we can write P power as force multiplied by the velocity. And this is a vector product. We have two vectors. So we have to add the cosine the angle. Okay. So P power now it's written as force multiplied by the velocity multiplied by cosine the angle. Okay, that's it for today. That's it for now. شرحنا الكونسبت والثيوري. إن شاء الله بالفيديو الثاني ببارت 2 we will solve all the questions that I told you about. Thank you for watching. Oh, see you next week.